and I would like to welcome Dr. Kingsley Ukoba, who is a lecturer and researcher in the Department of Mechanical Engineering Science at the University of Johannesburg in South Africa. And we've asked Dr. Ukoba to join us because he is a distinguished researcher and author with multiple engagements in international projects. And what we've asked him to do is to provide us with that overview of additive manufacturing. What are the key concepts? How did it come about, the history, as well as looking at some of the key project examples of how the technology is being deployed across Africa today. So really painting a broader picture of, and then also hopefully connecting some of the things you've heard in the in-depth case studies that we had this morning. And this also then segues over to the next sessions we're going to run in this event, which will include a presentation from WorldSkills and then a hands-on demo in Fusion 360 of particularly these concepts. So really an introduction to that so that we can then move over. But with that said, enough of me talking. Thank you so much for joining us. We're really happy that you're here, Dr. Ukoba. I'll hand over the call to you so you can share your presentation.
Okay, thank you so much, Thomas. I'm very happy to be here. I want to thank all the presenters that presented their work today, especially the previous one, Mr. Clinton, for laying the foundation. I don't know if you can see my screen.
We can see it.
Okay. So I guess I'll start straight away. Hello, everyone. Kingsley is my name. I'll be speaking on additive manufacturing, but my focus will be on 3D printing. This is the overview of my presentation. I will just like what Thomas have said, I'll try to lay a foundation both from the academic point of view and from the practical hands-on point of view. For people that are interested in making some read, there have been some publications on 3D printing in its application for housing in the UK. I recently wrote an article too for the American Society of Mechanical Engineers on how 3D printers can help solve the problem of pollution, climate change, and epileptic power supply in Africa. Basically, the word 3D printing, from the word printing that most of us are aware of, involves printing as it is, but in this case, you're printing in 3 dimensions. The D in the 3D represent 3 dimensions. So you have the S, Y, and Z coordinate for the engineers. So it means that you're printing something you can touch, including you can print your replica yourself or any object that comes in 3 dimensions. That's basically what 3D printing is all about. It's involved, depending on the type of printer you're using, building layer by layer on objects to achieve the desired objective. For the history, it's been around for over 80 years, but currently it's again prominent 40 years from now. There have been a lot of developments in terms of 3D printing, but the past 40 years really made 3D printing to come to forbear. So for someone that have background in conventional or computer numeric control, CNC manufacturing, you may want to draw a difference between what a 3D printing and CNC is all about. For CNC, it is suppression. You're basically shipping, milling, or trying to like a big block of object, you're trying to reduce it to the desired shape. But for 3D printing, you're building from bottom up. Then for 3D printing, you really don't need much of the bulk objects. You basically just need the filament or the resin to be able to create what you want. But for your CNC, probably you have a rod that you're trying to reduce to maybe form a shaft or whatever object you want. So it involves basically subtraction. While for 3D, it is an addition process. So the process of 3D printing starts from you having the 3D object you want to print. There are different ways that you can achieve the 3D object. One, if you have a sound knowledge of computer-aided design and manufacturing, you can build it from scratch, or you can go to some online. There are some sites or even software that already have it modeled. So all you need is just to customize it to the desired shape that you want. And then you can also use a 3D scanner. So you just scan the object that you're planning on printing. And after that, you convert it to the CAD model. Thereafter, from that CAD model, you convert it to your .stl file. .stl is stereolithography SLA, which is the first form of printer that was produced by Hall. But most of these computers, like Autodesk Inventor, they can save your CAD model straight into a .stl file, and then thereafter, the software will slice it and give it into bit by bit for the printing. So thereafter, you send it to the 3D printer. There are different classes of 3D printer depending on what you want to achieve. Then the 3D printer will give you the final product. So apart from .stl file, there are other file formats that you can save your computer-aided design objects into, and you will be able to use it to get your 3D printing sorted out. Some of them are .obj, .3mf, .pli, and .ply, and the likes. So there are different components that comprises or that make up the 3D printer. The major components are the one I've shown on the screen now. To the left of my screen, that's a Prusa fused deposition modeling and 3D printer with all the components labeled. The extruder, the print bed, the nozzle, the filament, or the resin, as the case may be, are the key components of your 3D printers. So there are different classifications of 3D printer. In some cases, you can classify it based on the material that you're using to print, if it is a filament or you're using a resin, or you can classify it based on the method that it's using to produce the material. So for material extrusion, you have the fused deposition modeling and the FFA, and then for other components, later on, I'll be talking about the SLA, the SLS, and the SLM. Now, for the 3D printer type, you have for the filament, it's just like a strand. You have ABS, PLA, ceramics, concrete, metals of different types, polymers, and the research and development on different filaments is still ongoing. So the list for now is still open for more things to be produced. And then you have the option of resin, as you see from my screen. The other type of 3D printers that you have is the selective laser sintering, the SLS, and the fused deposition modeling, polyjet, electron beam melting, and the likes, and the host of others. Just shortly, I will just try to give a topographic, a tabular difference between what these some of these printers are used for. Mr. Thomas, am I permitted later on to send the slide to everybody because of time so that I can just move on?
Sorry, I didn't catch all of that. Sorry, apologies. What was the question?
Will the slide be sent to all the participants later? So.
Yes, apologies.
Okay,
yes,
okay.
we are recording the sessions as well, so that we will include both in the follow-up. Yes.
Okay. Thank you very much. So these are just some of the differences between the different type of printers. Now, just these are also differences in some of the filaments, the difference between ABS and the polylactic acid, and then for the cementals. Then now, I decided to skip to this portion, application in Africa. At the moment, there is the rave about fourth industrial revolution. And we're still struggling in part of Africa to catch up with the second and the third industrial revolution. So it becomes scary for us that we are yet to grapple with the second and the third, and now we're trying, the fourth one is already in existence. But not to worry. For building, 3D printing can be applicable in building. Here at University of Johannesburg, Professor Mawala, who is the Vice Chancellor, so he's leaving to the UN University, recently started a project where 3D printer is used to print a building within a day. Yes, it is very possible for you to construct a 6-bedroom apartment less than 24 hours using a 3D printer that prints using cement. Portland's company in the US sponsored the research on how 3D printer can be used for printing of buildings, and they have gained significant progress in that. So there have been applications of it in different parts of the world, in the UK, even here in Africa, just like I said, in the University of Johannesburg, it's already been used to print a 6-bedroom building within a day. For electricity, 3D printing can also be used for a whole lot of things. In part of Africa, it will interest you to know that there are some places that the issue of electricity is have not been seen for this year. In some part of Africa, they've not even seen the lights bulb come on. Then here in South Africa, there have been the issue of load shedding, where maybe for 1 hour, 2 hours, the electricity will go off and all of that. 3D printing can help in this regard. 3D printing can help in crashing the cost of hydro turbine. Like the write-up I did, there is a company in Canada that currently using 3D printing to do a retrofit for wind turbine to increase the efficiency of such wind turbine. It's also possible for, just like the presentation that Mr. Clinton made, it's also very possible. One of the university, I think UNN, if I'm not mistaken, they did a Peton turbine. A Peton turbine allows overhead tank to supply the water that will turn the turbine blades to generate electricity. Almost all the components in that Peton turbine can be printed using a 3D printer. Yes, 3D printer, because a 3D printer can print stainless steel, it can print steel, it can print tungsten, it can print also plastics, depending on what the type of the 3D printer you're using and the filament. So the cost and the affordability is going to be reduced if there is such applications of 3D in electricity. What it means is that every individual in Africa and beyond can print their own electricity. What it means is you can go online, download a turbine of your choice, modify it with little or no skill, and with your 3D printer, you can print it and you can install at the back of your house or your wherever you are, and you generate electricity. 3D printing is also being used for educational purpose. Hitherto, in some part of Africa, what people do is that they just read things in books. Say in biology practicals, you see students memorizing a full human anatomy that they might not be able to, they will be able to understand better if this object is printed. A 3D printer can get all of this done. In the chemistry department at University of Johannesburg, almost all the chemistry experiments have been 3D printed, from the synthesis and the reactor done in chemistry. All of them have been 3D printed. So for food packaging, we recently collaborated with a department, the food department in UJ, to print cookies. Yes, biscuits. We were able to print biscuits using a 3D printer. We use the Anycube acrylic 3D printer in printing that biscuit. There are other research that we're currently also doing on how we can reduce termites and other insects from eating some of these equipment you use for packaging of your food, using antimicrobial coating for our 3D printing. There are a whole lot of applications that you can use the 3D printing for. This is a picture of the project that is being done in Malawi for 3D printing of houses. It means that with 8,000 or thereabout, you can print a house of your choice. This is the one that we did at the University of Johannesburg, a 6-room house that was built within a day. These are just some pictures. So on our screen here, we can see an engine block that was printed using a 3D printer. Now, for the entrepreneurial and the business aspect, for the students or for the fresh graduate or whoever that is listening to this presentation, the problem of unemployment is rampant in most parts of Africa. With your 3D printer, you can start your own business. You can become your own entrepreneur. It's already a lot of students that have gone ahead here in South Africa to do that. All you need is a 3D printer. 3D printers are very affordable with about 15 to 10,000 rand, with about 350,000 naira. Thereabouts, you will be able to afford a Prusa fused deposition modeling printer. This printer can allow you to print a whole lot of objects that you can sell to people, that you can use as a form of business. So 3D printing, apart from just the way the technology that is bringing for global or for the continental development, it can also be your go-to to take you out of that unemployment and that issues of financial scarcity or that problem that you're having. So there's a whole lot of things that you can do. And the good thing is that you don't really need to have a sound knowledge of CAD and CAM. As some of these parts are already online, like Tinker cards, you can use all of that. All you just need is just to customize it and it will get and serve the purpose for you. This is just like a video I tried recording for printing of a 3D object. In this case, it was a frog using the Prusa. Now, this 3D printer was manufactured using 3D printing itself. A gentleman started it just as a hobby, but now it's a big business for him. I think generating almost over $1 million in revenue for the gentleman. So there's a whole lot that you can do. It's a technology that you can start with as a form of fun and learning, but later on it can be what will give you the needed. So that's a frog that was printed using the Prusa fused deposition modeling printer. Thank you very much for listening. I will want to pause here for questions and any feedback. Thank you very much.
And thank you for sharing that overview and perspective, and as well as linking it to some really practical implementation of how it works. Yeah, so any questions from the participants, please feel free to put it in the chat window or Q&A. I see that there's a shout out, so it definitely was useful to receive or hear this overview, and hopefully, as I said, our intention was that it would put a frame around the different case studies that we heard this morning that touched on additive and 3D printing and make, etc. So I don't see any questions, but I see more shout outs. So again, thank you. that's great to see. And I can reiterate that we will be sharing presentation combined for the whole event. So there will be a combined email with all the presentations a few days after the event. And I see that there's a request to connect with you, Kingsley, after the event. So I know our team has already asked whether it's fine to share your account details. So I believe they will put that in the chat as we speak. So then you will have the contact details and to connect directly and follow up. So that's great, and that's another great outcome of this event if we can establish some connections on how to proceed with local collaboration afterwards. There's one question. It's about 3D printed components. So are 3D printed components very feasibly, especially pertaining to automobile products? I guess in automobile production, is that a feasible approach in terms of producing the components? Would you have any insight on that or any advice to share in that respect?
Say that again. I couldn't get.
So the questions are 3D printed components feasible when it comes to automobile products or automobile production? So is this, I guess it's about whether this type of manufacturing method would work well in the automobile industry.
Okay, yes, thank you. The major component of most of these automobiles is the engine block. And they have been the application of the 3D printing in printing the complete engine block. So to answer the question, yes, you can use 3D printer for the automobile industry. I think there is basically no industry that the 3D printer has not been used for. The only thing is that, like in the medicine, they've used it to print some component from the legs, some organs, and the likes. So yes, to answer the question, you can use it for automobile. It has been used for printing the engine block. The body of the car can be printed with it. So 3D printing, basically, just like you have your normal printer that uses a paper, uses cardboard or tape, the same thing with 3D printer. The key component, which is the filament or the resin, they have developed several materials that you can use for it, from tungsten to stainless steel to mild steel and the likes. These are the major materials, even composites, composite polymers. These are the major components that you use for your automobile. So it's possible. They've done it in some situations. It's possible to answer the question.
Perfect. Thank you. Yes, I hope that provides an answer. If not, feel free to post a follow-up. We also received another question, and it's about the how to optimize the strength of the material in additive manufacturing, especially for plastic printing using ABS and PLU and the likes. And I assume there's, again, some best practice advice or guidance perhaps that you could share in terms of optimizing material strength.
Yes, for the material optimization, depend on what you want to achieve. If it is strength, there are filaments that you can use. But in a situation whereby you prefer strength, oftentimes people use the resin, because the resin, you'll be able to mix it. You can add some ingredient or component to achieve the desired shape or desired property that you're looking for. So then for plastics, depend on what you are looking at. If you just a normal, easy to print, you can use your ABS or your PLA, that's polylactic acid. But if you want to achieve something with a better strength, you use resin, not the filament. The resin, you'll be able to mix other materials to it to improve the final product.
Thank you. I hope, again, that should hopefully provide a good answer to the question that was asked. I don't see any further questions in the chat, but we have now shared contact details, email, and also a LinkedIn profile. And I would encourage to connect, and hopefully we can form a basis for further conversation and development. So thank you again for joining us. We really appreciate it. It was very useful to hear your overview and perspective on the.
Thank you very much for the opportunity.
Excellent.
Cheers.
Great.